Yes, I am Jim Clegg. I've been interested in using Artemia as a model system for quite a few decades. Today, I'm going to address chiefly the abilities of the encysted gastrula embryo, which you see on the slide to the left. This is a hydrated Artemia embryo at the gastrula stage, surrounded by a very tough protective shell on the outside. This embryo is capable of resisting a huge variety of environmental insults. I will give one example to start, and that is its ability to lose virtually all of its water. All of its liquid water is lost by evaporation without killing the embryo. And I've been interested in trying to understand how this embryo does something that kills the vast majority of animals of any stage. Right. Very few creatures can withstand total desiccation as Artemia can. And that's why I said some years ago that we should consider the brine shrimp Artemia as an animal extremophile, because it has this astonishing ability to withstand stresses of various kinds. To the right, you see the dried cyst. It's very difficult. We found it impossible to get electron microscope images of the dried embryos. But at the light microscope level, they are amorphous. They seem to disappear into a background, and I'll give you a reason to suspect that we know what that is. Okay. Central to Artemia's abilities of various kinds is a disaccharide called trehalose. It's a molecule consisting of two glucose molecules hooked together in a certain way. And this trehalose, we believe, does two major things that is involved with the resistance of the Artemia embryo. One is that it serves as a water substitute. By that I mean, imagine the water being lost from a cyst by evaporation, and as the water is lost, this would normally result in the damage, denaturation of macromolecules of all kinds that rely on water for stability. And that includes membranes. And of course, cells are chock full of membranes of all kinds in different organelles. Now, we believe, on the basis of some evidence, not conclusive, we believe that the trehalose replaces the water that's lost, thereby stabilizing the macromolecules and membranes. So it is a substitute in that sense. Another function of the trehalose is to form a glass at very low water contents. When the water contents get close to zero, they never really get to zero, but close, the trehalose forms a glass. And as you all know, glass is a very stable structure in the sense that we know it, but trehalose glass is also very stable, and we believe, and have reason to believe, that the components of the Artemia cells in the cyst get embedded in the glass, in the trehalose glass, thereby becoming very stable and yet becoming reversibly functional. Okay, so the two major roles of trehalose being a water substitute and the formation of a glass.